Welcome, everyone. It's nice to be here in Kraków again for this year's droidcon. I already saw lots of familiar faces, but for the ones who doesn't know me yet, my name is Yasin Yildirim. I'm working for eBay in Germany, located in Berlin. Today I'm going to talk to you about the code quality, because lots of us actually are not evolved from Java, but we all started with, or most of us started with Android directly. That's why we actually don't care a lot about the Java code standards or the quality, the code quality. So I would like to give you some tips and best practices in this talk. And you can actually use this hashtag to tweet us. Before we start, I would like to ask how many of you here knows how many lines of code you have in your main project? Well, only 3, 4. Okay. Then from those, who has more than 10,000 lines of code? 20,000? More than 50,000? Couple of them. More than 100,000? Only one. Yeah, and one of the previous talks was, I don't see him here, but he mentioned 2 million. Good for you, man. I mean, not so good, but yeah. I'm asking this because when you have more code, you have more problems, obviously. You have more bugs and you have more quality issues. So this is just out of curiosity. I just had a look at AOSP line of code count. They have right now 13 million lines of code. Half of this in Java. Yeah, it's quite good. Half of this in Java, and of course, we here have like 50,000 or 100,000 lines of code, and we always have bugs and problems. And just imagine how they are handling this code base. It's amazing. Of course, with more code comes more complexity. This is the project I'm working on right now. In March 2015, we had around 50,000 lines of code. And the complexity of this code was 10,000. But what this number is coming from, where this number is coming from. So it's all the count of if, for, while, case, catch, throw, return statements if they're not the last statement of the method. And also these and, or, and ternary operators. So these are, whenever you use any one of these keywords or operators, you add one more complexity in your code. And this is showing a kind of timeline. 15 days ago, I checked these numbers. So I saw that we added 5,000 or 6,000 lines of code, but in the same time we added almost 2,000 complexity, which brings us like we increased the code 13%, but we actually decreased the quality because we added more complexity. There's actually, yeah, most of you know this. There's actually a very valid measurement of code quality, WTFs per minute when you're having a code review session. But not all of us are lucky enough to have somebody to check their codes, right? Not all of us are working in huge companies having code review sessions or something like that. So what we can do? There are actually lots of tools, but these are the most, let's say, popular ones. So find bugs is actually, these explanations are taken from each one's websites. So this is how they define themselves. So findbugs is a static analysis tool that analyzes Java bytecode, which is making it faster. PMD is checking for potential bugs and unused code. Check style is checking your code against some coding standards. And Android lint, most of us should know it, is checking your Android-related code mostly. Maybe I should ask how many lint issues you have. 0? 10? 50? 100? 200? Come on, guys, fix your codes, please. Here we have a quick comparison or explanation of each of these tools. So findbugs is working on the bytecode, and it's really fast, and it finds real bugs. PMD is mostly about bad practices or finding bad practices, and it also can find duplicate code. Check style, as I said, it's just checking against some code standards, for example, the Sun code conventions. And Android lint is dedicated to Android. It's checking your XML files and also Java files, but lint is very limited when it comes to checking your Java code. Then why don't we use them all together? So there are multiple ways of doing this, but the ones I really like is shown here. There's a Gradle way which you can use plugins for each of these tools, and you can run them at once, and you can find all the problems about your code. There's a very nice blog post here. I don't even know who wrote it, but what matter is the community, so we learn from each other. So please read this. And the second way of doing this is using a tool like SonarQube. What SonarQube basically does is it actually combines all of these, and you can actually create some your subset of rules which you want to apply to your code. Because not all of the Java style or Java code quality rules apply to Android. Some of them actually doesn't make sense for Android sometimes. And Sonar has its own rule set also. So additionally to find bugs, PMD, check style, and lint stuff, you can actually use their own rule set, which is called Squid. I'm going to show you how we use Sonar in our daily life. So whenever someone pushes something to GitHub, it triggers a build in Jenkins. Jenkins first asks Sonar, because Sonar has an API. Jenkins first asks Sonar, tell me the existing issues right now. And then starts the actual build. It builds our project, and during the build process, actually triggers the Sonar and gets the results from Sonar. After the build is done, it compares these results, and it finds the newly added ones. And the newly added ones are actually the last committer's fault, right? It uses the max say command, and it shouts in the office that this guy actually created 2 new Sonar issues. And it also posts this to Slack channel, so everybody knows that this guy created 2 new Sonar issues. Yeah. Yeah, exactly. We love blaming each other. Yeah, so you can check your code against these awesome tools, but actually you can avoid having code quality problems, right? So let's talk about some best practices. How can you make your code better, and also your Android structure a bit better? So let's start with the Android-related ones. So how many times you do this kind of layout with layout height in your one-day work. So I do it like average 15 times. Who else? Like 20, more than 50, maybe. Maybe you are working at a UI-oriented company. Yeah, so this is a lot of overhead, right? I mean, Android Studio right now actually is giving us the pre-written actually this stuff. Sorry, this stuff, but still typing wrap content match parent wrap content match parent. It's not gonna happen. Then why don't we extract the styles? So what we have is we have a style called wrap, and it has layout width and layout height. Whenever we want to use a view with a wrap content, we just use a style. Style is wrap, and we are done. We don't have to write any of these layout width and layout height. Same goes for match width and match width vertical, for example, for the orientation related stuff. Yeah, so just extracting the style gives you a bit less code in your XML files. You can also parent or inherit from styles, like normal Java extends, but in XML it's called parent. So what we have here is we have a base edit text style, which has our own text color, text hint color, or appearance, which is the size of the text. We actually extended this to use it for login fields. So login fields has match parent and wrap content size, and they are all single line and all those stuff. And then we extended the login field as username and password, because username has to have the style as email address, and it should have a next button in the IME. And also password field should show the password hidden. So I don't know what the pattern is really about, but we actually have a button to reveal the password, because when you're typing on a mobile phone, it's not that easy. And then in your actual XML code, you actually have one style here, and you're actually done. You don't need to write like 15 different attributes just to make one username field or one password field. So you just type one and done. And you can actually reuse these ones. In multiple places in the app, we have something like this. It's a full screen loading, and when the content is loaded, it shows the content. For this one, if we wanted to make it manually, like put a progress bar in each and every screen, we had to repeat a lot of code, right? Instead of that, we actually extracted the progress bar. So you can extract a layout as this, put your progress bar, because you want it to look and feel the same in every place in your application. So you just define a style here and how big it is, and then just include it wherever you want. So whenever you need a loading or full screen loading, you just put it there as an include. So another question comes here. This is a very simple screen which has a couple of images, then text and text and text, and 2 buttons. Who thinks this is one activity with lots of views inside? One, half. And who thinks it's multiple fragments in one activity? No fragments at all. The answer is, here are lots of fragments. Because single responsibility principle. I will explain now. So if we had one single activity, we would have the views, all these views, as members of the activity so that we can reach them. We have to use a view binder or initialize the views in onCreate, or we have to request the data and handle the result in one single activity, which is a class. So, and then this guy will need images loading or lazy loading the images and all the view pager logic. These are dynamically created views, and you don't know how many of them you will get. This is a very particular example, actually. So you have to request the visitor counter for this item and show it separately. And all this stuff, getting some data and binding it to multiple views, and also click listeners. But when we do this in multiple fragments, activity will have the responsibility of only hosting the fragments and nothing else. Hosting fragments, get the data, distribute it to fragments, and done. And then the simple fragments, this guy will do the image logic. We can reuse these guys. This can do its backend request and get the result. And we can reuse multiple stuff actually from here. And actually, your layout for that one single activity will look as simple as this. So probably here we have like 5, 6 fragments, and you will only have 6 fragments here and nothing else than that in the activity. So the layout looks much simpler, and you know where to find which information. So if you want to deal with the image logic, you just go to the image fragment and do your job. And with this way, UI parts are easily exchangeable. So if you are on a tablet, you can lay out them differently and align them differently because they're fragments. It's very easy to move them around. So this is much of a personal preference topic, let's say. We often do this kind of stuff, right? Button.set on click listener. New, we on click listener because Java allows us to do. And we just put shitload of stuff in this on click method, do everything there, and we are already lost in this part of code. But instead, you can actually extract that class as a nested class and use just my button click listener, done. And this class has its own responsibility now. Of course, as I said, this is a personal preference, and what I prefer is, if it's just a one-liner, I prefer the anonymous pattern, but if it's more of a complex class or reusable ones, I try to use the nested one more than the anonymous one. The code part you see on the right side of this screen is a complete garbage, and let's explain why. It has an unused private field. It has an unused private method. And actually, you maybe wanted to use this method in the future. You just wrote it and it stayed there. And the class itself is not used at all. So we can completely clean and remove all of this code. So please remove all unused fields, methods, method parameters, which is the dummy here, for example. We don't do anything with that dummy parameter. Unused classes and future-proof code. Please don't write methods or classes for future usage, because you don't want to solve a problem you don't have. In the beginning, we talked about complexity, and let's have a look at the cyclomatic complexity, which is a bit hard to understand, but I will try. So in order to understand the cyclomatic complexity of a method, there's one way to do it. You can create a flowchart of this method, which takes like, I don't know, 15 minutes or 20, depending on your method's complexity. And then there's this very simple formula you can use. You get the number of the edges, you get the number of the nodes, and the nodes which has exit points. And we calculate this method's complexity as 4. But there's an easier way, of course, to do this. Remember the keywords I told just in the beginning of this talk? You just count them, and you just add 1 for the method entry point. So in this method, we have 3 if statements and 1 for the method entry point, and you have complexity of 4. But why am I telling this complexity stuff? Because if your method has 1 to 4 complexity, it is low complexity. If it's 5 to 7, it's moderate. If it's 8 to 10, high. And if it's 11 plus, it's a no-go. You should definitely refactor that method and split it into multiple methods, because you are doing lots of things in this one method. So in this case, I was lucky. I had only 4. But sometimes readability is more important, right? So you have this kind of stuff, maybe, at some point in your code. So if this, do this. If else, do return this. But the complexity of this method is 16. This is what Sonar tells me. I tried to actually simplify this method a bit, and I made it to this size. I reduced the complexity to 8, I believe. But still, 8 is a high complexity, right? But come on, readability is, or understanding what you did 2 weeks later is much important than the cyclomatic complexity sometimes. So here we have some nested stuff. We have 5 if, 4 if nested inside each other. So this can actually go further. Even you can have 7, 6, 8. No, 6, 7, 8. I'm sorry. But the right thing to do is you should actually split this method into 2 different methods, because you're doing lots of things in one method still. I feel like I'm repeating myself, but yeah, you're doing lots of things in this method, and it's better to understand this structure when you read this code later. The rule, I believe, says more than 3 is not allowed. So more than 3 nested control flows are not allowed. So that's just the reference. Who does this still? Please, no one. Cool. Yeah, we do not catch throwable, right? But why? Because of this. Throwable is the parent class of error, exception, and some stack recorder from Sun. I have no idea. This leads us to catch actually errors, all the errors which can be thrown by the system, right? So out of memory error, it's not an exception, it's an error. So if you catch an out of memory error, what do you do? Nothing. You cannot do anything with that. So you can, if you can't avoid it, then don't try to catch it. And same goes for the exception, actually. So the generic exception, which is called here. Probably out of laziness, this cleanup all method can throw exception, because it can throw exception 1, 2, 3, 4, maybe. And in this method, actually, you had to write catch exception 1, catch exception 2, catch exception 3, but I was too lazy to write that. But what happens in real life is this guy can fail, right? This guy can throw an exception, which I do not expect, because this is an array, and the array can be null. If I get a null pointer exception here, it will go here, and it will come here. It's an exception. I mean, on pause method, I just ignore it, and I didn't remove my listeners. And I'm leaking memory now, because all the listeners are bound to my activity at that point. So if I get any unexpected exceptions, it's just bad with this one. So we have to be specific about what we expect to be thrown, and we have to catch those, and the others actually should warn us before we make a mistake. Let's talk about the class size a bit. So this class has like 15, 16 fields, which are actually not that much related to each other. It's a user profile, so it has username, surname, initials, blah, blah. But it also has the location ID, street number, and all the address fields, right? So this class has too many fields, and it's usually assigned that it can be split into multiple classes. Why don't we do like this? We create one more class, which is called user address. We put all the address related stuff, for example, there, and use it in our user profile class. And that's it. Yeah, we do this a lot because of laziness, probably. We just need one more parameter, we add it into the method. We just need one more, we add it again. And the parameter list goes bigger and bigger and bigger. Yeah, similar to what we did in the class example, you would probably create another class for the address-related stuff here, for example, and pass that as one object. Too many complex conditions are also a bad practice. So here we have like 6 different conditions we are checking, and these are all Booleans. They can also be methods which are returning Booleans, and this is not so nice. So this actually can be optimized as this. Yeah, this actually translates directly into this, and you have 2 conditions in this method, 3 here and 2 and 2 here. This adds a bit more complexity, but it reads better. Utility classes are actually not meant to be initialized, right? So we have this string utils method. It has public static, string utility utils class, which has 2 public static methods, and you can reach them directly. So make the constructor private, and additionally, you just throw an exception, because you don't want this to be instantiated anyways. You just throw an exception, and whoever tries to do that will take it in his face. Yeah. Another random fact that we do these kind of things in onResume and onPause, do something other, and at some point in time, we just don't want to do that anymore, and we just comment it out. And we check if it works as I expected, and the code lives like this for the rest of his life. But actually, here you don't do anything else than calling super, right? So overriding is a good thing when you're actually doing something, but if you're not doing anything, just don't override and just delete these 2 methods. Let's talk a bit about string operations. Yeah, as a lazy developer, I also actually used to do this a lot. You have an integer and you want to get it as a string, you just add an empty string to that and you get the string value, right? No. Because this is translated to this. So it creates a string builder, appends the integer.toString, appends the empty string, and gets the toString of that string builder and tries to give me one string. Instead of this, we just do a string.value of value. Or because the value of method of string actually internally calls integer.toString, we just use integer.toString. It's a very convenient way. Similarly, when you're adding something to another string, it can be an object, it can be a primitive type. We do something like this, and we got our string actually price 200 zlotys, and done. But this is bad. What we should do is actually either do this, get the toString, and avoid the string builder creation, or doing more things for the same thing. Or you can actually format the string as this. But there's one and even better way for Android. What you can do is you can create a localized string for that, because you can have multiple versions of this in English, in Polish, in German, in Turkish, anyways. And then you just use the getString method of your activity, or actually it comes from context. And you can actually parameterize the getString method and achieve the same thing with this, even better with localization. Please tell me that you're not doing this with strings. Equals operator. Cool. I was actually quite surprised when I saw the equals implementation of Java. It actually does a lot of things, and it really ensures that two strings are equal. So it checks the length of the strings, it checks the hash codes, and it checks the characters one by one just to ensure that these two strings are equal. So please use the equals method of string. That's much more convenient. Equals method of string, actually, let's start with this one. So we say this is good, right? And we continue from that. Equals method of the string returns a Boolean. And we here wrapped it around an if-else. Why? We could actually do just like this. Just return whatever equals tells us. Similarly same thing goes for comparing Boolean values with true or false. It is not giving any extra advantage to you. So just use the Boolean value directly. Thread and runnable classes, they both have a run method. And maybe some of you tried to use that run method. But when you do this, actually it doesn't create a new thread. It just calls a method inside that class. Instead of this, if it's a thread, you should use the start method of the thread. Or if it's a runnable, you just wrap it into a thread and start that thread. Probably this is one of the last ones. Please give meaningful names to your fields and methods. So here we have a user class, which has a code, which is described as phone operator code as a comment, but none of us read comments, right? And it has a tell, and it has a get tell no, which actually doesn't return. It's not a real getter, but it actually does something else. Instead of this, we should give really meaningful names, even if they are too long. So when you're reading this code, you actually know what the code is all about, what the number is all about, and what this method actually will do, just reading the method name. So your code should be self-explanatory, and you shouldn't need that much comments. As a closing sentence, one of my favorites from Martin Fowler, Any fool can write a code that computer can understand, but good programmers write code that the others also can understand. Thank you for listening.